everyone, in this video we are going to be going over adding and subtracting fractions. Our essential question for today is, how is the sum and difference of fractions calculated? How is the sum and difference of fractions calculated? Now there are two different methods for adding and subtracting fractions, and we're going to go over the steps for each of those. You can choose to use either way on your homework, classwork, quizzes, test, or you can even use both of them at different times. It's completely up to you. Our first method for adding and subtracting fractions is to keep the fractions proper. In this method, you would first start with adding or subtracting the whole numbers. You would find the least common denominator of those fractions to create equivalent fractions. You would add or subtract the fractions together and simplify if needed. With method number 2, you would keep them you would change them to improper fractions. You would first convert the mixed number into an improper fraction. You would again find the least common denominator of those fractions to create equivalent fractions. You would also add or subtract the fractions and simplify if needed. And it really depends on which one you're more comfortable with. Every year it seems to be about 50-50. Each student has their own way that they like solving these problems. Personally, I tend to kind of bounce back and forth between both of these, but if it matters at all, as we get further into Math 8, we tend to work a lot more with improper fractions and also leave a lot of our fractions as improper. So that is something to keep into consideration as well. So first step, adding fractions and mixed numbers. So in each of these examples, I'm going to go over both method. It doesn't mean that you need to write both of them down. I would choose to write down the method that you're more comfortable with, or if you're not sure which one you want to work with yet, write down both of them. All right, so in this example, you can see that we have two fractions and the denominators are not the same. So our first step is to make these denominators the same. And the way that we're going to do that is by creating equivalent fractions and multiply these fractions to have the same denominators. And so in this one, we can see that 8 and 2, their common denominator would be 8. And what we can do is that we would actually leave this side the same, and we would keep it as multiplying by 1, because then that keeps this fraction the same. But on the right side, we would multiply it by 4 over 4. By doing that, we end up with a denominator of 8 and a new numerator of 4. But as you can see, this one on the left stayed exactly the same, because our goal is to get two fractions that have the same denominators. Because when they have the same denominators now, we can add the numerators across. So 8 plus 4 then is 12, and 2 plus 4 is 6. So it gets very easy to add once we have common denominators. And if you can simplify, you have to. And in this case, we can divide both the denominator and numerator by 2 to give us 12 and 3/4. So that's the method that you would use for proper fractions. But here's also the method for improper fractions. In this method, you would first create improper fractions. And the way that you would do this is by multiplying the whole number and the denominator, and then adding it to the numerator. Okay, so 8 times 8 is 64, plus 2 is 66 over 8. Okay, so we know this is going to be 66 over 8. And over here, 4 times 2 is 8, plus 1 is 9 over 2, because you keep the same denominator. Now again, the denominators are not the same, so we need to create equivalent fractions by finding a common denominator. And earlier we found out that that is 8. So this left side we multiply again by 1, and the right side by 4. The left side stays the same, but when we finish multiplying, we end up with 36 over 8 for that right fraction. And now that the denominators are the same, we can just add across as the numerators. And 66 plus 36 is 102 over 8. Or if you change it into an improper fraction, it's 12 and 6/8. Now you have to reduce, and when you divide by 2, you end up with 51 over 4. And you can leave it as either improper or proper. When you do your quizzes, tests, or homework, both answers would be correct. And if you're not sure how to get your improper fraction into a proper fraction, you simply divide. So 51 would go on the inside and 4 on the outside. 4 goes into 5 once. 5 minus 4 is 1. Bring down the 1. 4 times 2 would give us 8, with a remainder of 3. The 3 would go in the numerator, and that 4 that we divided by would go in the denominator. So just kind of a quick refresh if you don't remember how to do that. But I believe all of you guys should have done that a million times in elementary school. Alright, now let's look at adding mixed numbers with negatives. First, with proper fractions. Say that we've got negative 3 and 5/6 plus 1 and 1/4. Our first step is to get equivalent fractions. And 6 and 4 both go into 12. So that means this fraction over here is going to be multiplied by 2 so that that denominator becomes 12. And this fraction over here is going to be multiplied by 3 so that denominator becomes 12. And if you multiply by one of those numbers in the denominator, you also have to do the same in the numerator. Because whatever you do to the bottom or the denominator must also be done to the top or the numerator. And so when we finish multiplying, we get 2 new fractions that are equivalent to our previous fractions. They're just a little bit bigger. But this time we're working with negatives, so you have to remember those negatives rule. And that if the signs are not the same, you have to subtract. So even though we see that addition sign, we're actually going to subtract. And negative 3 plus 1 is a negative 2. Okay? And 10 plus 3, normally we'd think 13, but remember this is working with negatives, and so we have to subtract since the signs are different. So 10 minus 3 is then 7 over 12. And it cannot be reduced, so that is your final answer. Now let's look at it with improper fractions as well. So first thing, you have to change into improper fractions. Okay, so again, you multiply the whole number by the denominator. 3 times 6 is 18, plus 5 is 23. So 23 goes in the numerator, and you keep the denominator the same. You do have to make equivalent fractions and get a common denominator, and we know that that common denominator is going to be 12. So we have to multiply this left fraction by 2, and this right fraction by 3. Okay, so when you finish multiplying those fractions, you end up with a negative 46 over 12 plus 15 over 12. And since the signs are not the same, you subtract to get negative 31 over 12, which is the same, and when you change it into proper, it would be negative 2 and 7/12. Now, personally, even though the improper one looks like it has more steps, I like to use that with negatives more because I think that it tends to be a little more accurate and you have less likelihood of creating errors or having problems within your math. However, again, it is up to you and which one you want to use. All right, now let's look at a couple examples of subtracting fractions and mixed numbers. Oh, I went a little too fast. Okay, so in this example, we've got 8 1/8 minus 4 3/4. And one thing to note on this is that the second fraction is bigger than, well, if you ignore the whole numbers, that second fraction, 3/4, is bigger than 1/8, which is going to be something we're going to have to work with later. Now our first step is to get common denominators. And again, the common denominator between 8 and 4 would be 8. So we're going to multiply this left side by 1 and the right fraction by 2. So the left fraction stays the same, and then the right fraction becomes 6 over 8. Now, the thing that you see here, like I mentioned just a second ago, is that that right fraction is bigger, and you can't subtract 2, or you can't subtract 2 or 6 from 2, okay, because this one is too small. You'd end up with a negative. So what you have to do is you kind of have to rewrite this fraction, okay? You have to take 1 away from the 8 and make it a 7. Your denominator will stay the same. And then when you take one whole away, so imagine there's like this 1 floating out there. This 1 is also an 8 over 8, because any fraction over itself, any number over itself, is a 1. So we've got this 1 that we just took out right here. And what we're going to do is we're going to add that 8 over 8 to 2 over 8 to give us 10 over 8, so that it is now bigger than that 6 over 8. One way that I do it, and it's not the most mathematical way, but it's kind of a trick, is I go, okay, when I borrow from the 8, I keep that number goes smaller, so it goes 1 less. I keep the denominator an 8, and then I just add the numerator and denominator to get my new one, which is 10 over 8. That's kind of my trick sometimes. So, okay, so now we've got this fraction that looks like this, 7 and 10 over 8, and I can easily subtract them to get 3 and 4/8, which reduces to 3 1/2, which reduces to 3 1/2. All right, now let's look at improper fractions. So we've got the same problem, but this time we're going to change into improper, and I'm going to go a little bit quicker on this one because I think you guys know how to change into improper fractions. Again, we need to make common denominators, and the left fraction is going to be multiplied by 1 and the right by 2. So I get 66 over 8 minus 38 over 8. And when I subtract, I end up with 28 over 8, or 3 and 4/8. And you have to make sure that you reduce, which gives us 7 over 2, or 3 1/2. On this method, personally, I also like using improper fractions because I think a lot of people get messed up right over here. So when they have to change and borrow, a lot of people make mistakes, or this whole concept over here of borrowing on a fraction can be very confusing to some students. So personally, again, I like using improper fractions, but it's really up to you, and you might have been taught another way that makes more sense to you. All right, last example, this one with some negatives. And there is a subtraction sign that disappeared right here. So there's actually a subtraction sign. Oh, so I don't know why. There we go. Looks like I can at least write it in. So first step is, remember, when you're subtracting negatives, you need to add the opposite. So what I end up doing is I end up changing this to addition and this to a positive. And I just rewrite it. And again, I don't know why the negatives are disappearing off there, but we can just write it in. Okay, so adding the opposites, and that will make it to where we can just follow these adding integer rules to solve this problem. But first step is that we need to make common denominators. And a common denominator between 5 and 3 is 15. So that means I'm going to multiply this side by 3 over 3 and the right side by 5 over 5. Okay? And so when I do that, I get new fractions that are equivalent to the previous ones, but are both having the same common denominator, so that I can add or subtract them together. Now, if you remember, the signs are different, so they are the opposite, so we need to subtract. So negative 3 plus 2 is a negative 1, and 9 minus 5 is 4. So I get negative 1 and 4 over 15, which, that's why it got messed up, because I think I left the negative out. So negative 1 and 4 over 15. All right, so same thing as before. We need to first change it into where we add the opposite. And I'm going to have to fix this as we go along. Okay, so then we need to change to improper. 3 times 5 is 15, plus 3 is 18. So I get negative 18 over 5 plus 7 over 3. Okay, and I'm just going to write the rest of these in from here because it's probably going to be wrong. So since the signs are the opposite, we have to remember, okay, we have to first put into common denominators. And so we will multiply the left side by 3 and the right side by 5. And then what that will give us is that gives us a negative 54 over 15 plus 35 over 15. And since the signs are not the same, we end up having to subtract. So negative 54 plus 35 is a negative 19, because we have to take the higher sign, which makes it over 15. And you can leave your answer like that, or like we did before, you can, I think I went off a little bit, negative 29. Sorry, negative 29 over 15. or you can change it into proper as well. Again, personally, I like using the improper fractions, as though it looks super messy on this side because I had to clean it up a little bit. I just think that you run into a lot less errors when you use the improper way of adding and subtracting fractions. Okay, so that is pretty much it. You've got 4 practice problems, and those are going to go on that foldable that you were handed out. Make sure that you write the problem down, because I did not include that on those papers this time. So make sure you write that down, and that is it. Make sure you also input these into Edpuzzle, and if you have any questions, let me know.